Hello there, AP Environmental Science class. Welcome back to my lecture on Chapter 16, Environmental Hazards and Human Health. In the previous lesson or lecture, we began to speak about some of the issues that are involved in hazards and human health. Specifically with human health, we talked about pathogens, viruses, bacteria, etc., that could lead to disease. We then transitioned over to chemicals that could cause hazards, and that's where we are right now, kind of in the middle of talking about chemicals and how those chemicals can produce environmental hazards, not only to the environment, but also to the health of human beings. So some chemicals can affect our immune and nervous systems. What is the immune system? Well, the immune system protects the human body against disease. Arsenic, methylmercury, and dioxins can weaken that immune system. Again, we're talking about chemicals now. We spoke about, for instance, the HIV virus, which obviously makes the immune system weaker, but that was more of a pathogen, right? A virus. Now we're talking about chemicals. Neurotoxins can harm the human nervous system. Examples are the PCBs that we left off in the first part of the lecture on this chapter. Again, arsenic, lead, and certain pesticides can be classified as neurotoxins. Methylmercury, especially dangerous. Again, we did talk a little bit about mercury and how mercury can be biomagnified as it goes up the food chain. So again, especially dangerous there. So here we are, just looking at some of these chemicals and how they can affect our immune and nervous systems. So again, you have inorganic mercury, elemental mercury here that can go into the water and then again be eaten by fish, bacteria, algae in the water, and it then gets magnified as it goes up the food chain. You'll notice we have human sources of mercury and sulfur dioxide that again are pollution that can become into the air, and then precipitation brings that runoff into the lakes, where again, then those chemicals get biomagnified as they go up the food chain. So again, just understand some of these chemicals, understand how they get into the food chain, and understand that they can be neurotoxins and can definitely affect the immune and the nervous systems of human beings. All right, so next, we're going to talk about chemicals that can affect the endocrine system. What is the endocrine system? Well, they are glands that release hormones that regulate bodily systems. So some of those systems, they control sexual reproduction. These are the endocrine system, right, with the hormones. They control growth, development, learning ability, and behavior. We have something called HAA, which are hormonally active agents. They're also called endocrine disruptors. They basically have similar shapes and bind to hormone receptors, but they're not the actual hormone that is released by the endocrine system. And so then you have issues with sexual reproduction, with growth, development, learning, and behavior. So you can get some issues because of this. So again, what are the hormone mimics? Some of these mimics, one of them called BPA, biphenyl A, which mimics estrogen. You may have heard about this in baby bottles. There was a large push years ago to have baby bottles that were BPA free because some of them were finding that the plastic in the making of these baby bottles actually mimics the estrogen, and we're going into the baby through the formula or through the breast milk that was pumped and put into these bottles, and then that was causing birth defects, or not necessarily, the baby was already born, but defects to the young child that is growing up. We have hormone blockers, thyroid disruptors, perfluorinated chemicals, PFOAs, used to make nonstick cookware, actually has been linked to thyroid disease, cancer, and birth defects. And then we have these polybrominated diphenyl ethers, PBDEs, which are in fabrics, furniture, mattresses, and plastics that also are thyroid disruptors. So talking more about mercury pollution, obviously mercury can affect the endocrine system as well. Some of the solutions to help us with mercury pollution, prevention, phase out waste incineration because we're getting mercury into the air that way, remove mercury from coal before it's burned, switch from coal to natural gas and renewable energy resources to take away that mercury. How can we control, sharply reduce mercury emissions from coal burning plants and incinerators, label all products containing mercury, and collect and recycle batteries and other products that have mercury in them. So going back to the endocrine system here, Not exactly sure why the book puts that slide in between these two, because it seems like that Mercury slide should have been somewhere else, but obviously understand what's going on there. So back to these endocrine basically blockers, or these endocrine these things that these mimics, right? These blockers or these mimics. So what happens is each type of hormone has a unique molecular shape that allows it to attach to a specifically shaped receptors on cells, right? So we have these hormones, there's a receptor on the cell, and the hormone binds to that, and this then provides ability for growth and development and learning and things like that. However, we have these hormone mimics, or these hormone blockers that, again, certain pesticides, other synthetic chemicals called these hormonally active agents, or HAAs, can actually mimic or block the regular hormones from getting to the cells. You'll notice they have the same type of receptor as you would need, but they're not the actual hormone, okay? So the problem is then you get these mimics or these blockers to then bind with the cell, and now you don't have that cell developing properly. So again, it could lead to learning disabilities, could lead to stunted growth, things like that, because we're not getting the actual hormone that regulates these bodily functions through the endocrine system into the cell. You're basically either mimicking or blocking the hormone from getting there. So the chemical needed to have the cell develop properly is not getting into the cell, and then that can cause issues for the human body. So again, these are these HAAs. They mimic or block hormones, and that can, again, mess up the endocrine system, which, again, regulates a lot of bodily functions. And then those bodily functions, unfortunately, become unregulated, and then you can have death could occur, or severe issues to the human body. So what can you do? Again, exposure to these hormone disruptors. Eat certified organic produce and meats. Avoid processed, prepackaged, and canned foods. Use glass and ceramic cookware. Store food and drinks in glass containers. Use only natural cleaning and personal care products. Use natural fabric shower curtains. Don't use vinyl. Avoid artificial air fresheners, fabric softeners, and dryer sheets. And use only glass baby bottles and BPA-free cups, pacifiers, and toys for babies. And again, most of them are now, but you'll see them all over. Maybe in 10 years or so, you guys will become mothers and fathers, and you'll definitely see this stuff. So again, you want your baby bottles, your pacifiers, your toys to be BPA free. All right. So again, you know what to do with these charts. Just kind of have an understanding of what you can do to basically limit your exposure to these hormone disruptors, just in case you may need to pull it out for an FRQ. All right. How can we evaluate risks from chemical hazards? Well, there are methods to estimate the toxicity of certain chemicals. We can use live laboratory animals. We can have case reports of poisoning. So when people do get poisoned, if you have case reports, you can study those. And epidemiological studies as well can determine how risky a certain chemical is to the human body. Many health scientists call for a much greater emphasis on pollution prevention to reduce our exposure to the potentially harmful chemicals. So many factors determine the toxicity of chemicals. Basically, toxicology is the study of the harmful effects of chemicals. So dose, right? How much of the chemical you actually get. Age is going to determine the toxicity. Your personal genetic makeup, multiple chemical sensitivity called MCS, the solubility of the chemical, the persistence. Is it around a lot? Do you keep getting it? Keep getting exposed to it over and over again? And that biological magnification that we talked about when that chemical goes up the food chain. Synergistic interaction. This is the effect of two or more agents interacting together is greater than the sum of those agents. And a response to a chemical can be either an acute response or a chronic response. Acute effect is going to happen immediately immediately or rapidly. Chronic effect is going to be a permanent or long-lasting effect. So, for instance, an acute effect would be, something like cyanide. You take cyanide, you're pretty much going to die right off the bat, right? Chronic effect could be something like exposure to sulfur dioxide in the air, right? You're not going to die right away, but over the course of years and years of you persistently being, that persistently being exposed to sulfur dioxide could produce lung issues down the road. So again, that would be more of a chronic effect. All right. So again, two type of responses to chemicals, acute or chronic. There is a case study in there talking about protecting children from toxic chemicals. An analysis of the umbilical cord blood was done, and it found that 180 chemicals that cause cancers in human or animals are actually in some of that umbilical cord blood. Infants and children are more susceptible. They eat, drink, and breathe more air per unit of body weight than adults, right? Think about it. They're much smaller, so you have the same amount of dose of a chemical to an adult and to a child. It's going to affect the child more because they're just smaller, right? They don't have as much body weight there to maybe dilute the chemical. Exposed to toxins in dust and soil when they put objects in their mouths, right? If any of you have been around children, they're always touching stuff, always putting stuff in their mouth. They also have a less well-developed immune system, right? So obviously, if they are chemicals, if they're given chemicals or if chemicals are put upon them because their immune systems are not as well developed as us, you're going to have issues as well. So that's why infants and children definitely are more susceptible to these toxins. So scientists use a variety of tests to estimate the toxicity of certain chemicals. Studies usually involve live mice and rats because they have systems similar to human systems, and they're small and they can reproduce rapidly. So you can see how the toxic chemical is passed along to generations rather quickly. There's also something called the dose response curve and the median lethal dose, which is LD50. That basically is saying when you reach LD50, that's the median. That means half of the organisms are dying, half of the organisms are living. Again, you give an organism like a mouse or a rat some chemical, and then you keep increasing the dosage of that chemical. When you get to the point where 50% of the rats are dying and 50% are living, that is called the median lethal dose, or the LD50. There's a couple of threshold models out there. One is called the non-threshold dose response model, we'll look at in a second, and the other one is called the threshold dose response model. So let's take a look at what these models are. Basically, non-threshold means that as soon as you get a dose of chemical, you begin to feel an effect of that chemical. And the more dose you get, the more effect you feel. Basically, a direct relationship. As the dose increases, the effect that you have increases as well. And there's no threshold, meaning the minute you get a little bit of that chemical, you start to exhibit adverse effects. The threshold curve here basically says that you get a dose, but you don't begin to feel effects until you get more of the chemical. So you'll notice right in here, you're getting a dose of the chemical, but there's no effects. Finally, then you do feel effect, and then it is a direct relationship. As the dose increases, the effect increases as well. But again, it doesn't. That effect doesn't happen right off the bat. It takes some kind of threshold of dosage of that chemical for your effect to begin. Then the unconventional would be something where the dose increases the effect, and then as the dose continues to increase, the toxic effect would maybe lessen. That doesn't happen that much, and that's why that's called an unconventional. So just understand what these curves are telling us about the dose and about the effect. And again, that LD50 would be, again, where 50% of the organisms that are exposed to that particular dose die, 50% are living. Once we get to that threshold, we call that the LD50, or the lethal dose threshold. More human, we need more humane, though, methods than using animals. So obviously don't like to necessarily use animals. So you could replace animals with other models like computer simulations, or maybe take tissue cultures and individual animal cells and, practice or experiment with the dose on those tissue cultures and individual cells instead of an animal on its own. Effects of mixtures of potentially toxic chemicals are very difficult to determine, and that's because you don't if you mix chemicals together, you don't necessarily know which one is having a more effect or which one is having a lesser effect, and so it's very difficult to determine those effects when you mix potentially toxic chemicals. All right, so there are trace levels of toxic chemicals harmful. Well, unfortunately, there's insufficient data right now for most chemicals to actually answer this question. More research is needed. We are all exposed to toxic chemicals, but in a trace amount. So again, we don't know exactly if these trace amounts are going to lead to problems because we don't have enough data. So here is just a house, and it's just showing us different types of toxic chemicals that are found in our homes. And again, most of these toxic chemicals are in a very low dose, to a point where we're really not seeing effects, right? It's that threshold model. But it's interesting to know, shampoos, for instance, have perfluorochemicals to add shine. Some teddy bears are stuffed with some stuffed animals contain flame retardants and or pesticides. Food, again, some food can contain that BPA. Some fat in milk can contain dioxins. Water bottle, again, can have that BPA. Computer, flame retardant coating of plastic casing and wires, right? Tennis shoes can contain phthalates, for instance. Again, these are just chemicals. Mattresses, flame retardants in stuffing. That's a toxic chemical. So again, you don't need to memorize all of these, but do have a general understanding of some of these toxic chemicals that are found in everyday items. Again, very low dose, trace amounts. Again, you're not going to necessarily see an effect from that teddy bear that you may be cuddling with at night. But again, we don't know exactly because we haven't done a lot of research if there is going to be some effects, some long-term chronic effects. Obviously, you're not getting acute effects from that teddy bear. You're not dropping dead right there when you hug it. But who knows, down the road, 30, 40, 50, 60 years from now, maybe there will be some issues with these trace amounts of chemicals. So again, as you guys are heading into the workforce in a couple of years, maybe this is an area of research you want to take up, right? Taking up these trace amounts of chemicals and seeing if they do end up producing any chronic effects. So why do we know so little about the harmful effects of chemicals? Well, there are several limitations in estimating toxicity levels and risks. Only 10% of over 85,000 registered synthetic chemicals have been thoroughly screened for toxicity, and almost 100%, right? 99.5% of chemicals used in the United States are not supervised by the government. So you can obviously imagine why we know so little about the harmful effects. So because of that, what should we do? Well, because we don't know the harmful effects of a lot of these chemicals, we should be basically subscribing to the precautionary principle. All right. So what does the precautionary principle says? It says those introducing a new chemical or new technology need to follow new strategies. Basically, what they're saying is that a new product should be considered harmful until it is proven safe, right? Kind of the opposite of our jury system, right? In our jury system, you're assumed innocent until you're proven guilty. Well, the precautionary principle is the opposite. You need to be proven guilty or you need to be assumed guilty until you are proven innocent, right? That's what we're basically saying here. We need to assume a product or a technology is harmful until we can prove that it is safe. Obviously, that's not done right now, and that's why we don't really know a lot about the effects of a lot of these toxic chemicals. If we used the precautionary principle, then we would, because we would not use it until we prove that it was safe. Existing chemicals and technologies that appear to cause significant harm must be removed. In 2000, there was an international agreement to ban or phase out the dirty dozen persistent organic pollutants called POPs. So that has definitely helped us. In 2007, the European Union enacted REACH, which requires the registration of untested substances, most hazardous substances not approved for use if safer alternatives exist. So the European Union did this a bunch of years ago. In 2011, the EPA here in America issued new pollution prevention standards that really looked at mercury emissions from coal burning plants, trying to reduce those mercury emissions coming out of those smokestacks. And the Minamata Convention, the goal was to reduce those global mercury emissions. Because again, we're saying with the mercury especially goes into the lakes, but gets biomagnified. And then by the time us at the top of the food chain eat that fish, again, it has large amounts of mercury that are producing some chronic effects. It has worked. All right, so this is a success story. The 3M company, from 1975 to 2015, they prevented more than 2 million tons of pollutants from reaching the environment, and it actually saved the company close to $2 billion. So again, there is a money factor involved in pollution prevention. You can save your company money. Again, there may be some initial startup costs or initial capital needed, but you'll make up that money rather quickly. They also have an employee reward program for projects that eliminate or reduce a pollutant. So that actually gets their employees to come up, their think tanks to come up with ideas to eliminate or reduce a pollutant, and they actually get rewarded. If more companies did this, I would suspect that the pollution, the chemicals out there would be greatly decreased. So, how do we perceive and avoid risk? Well, ways to reduce risk: become informed, think critically about those risks, and make careful choices. So, the last thing we're going to talk about is the greatest health risks, and they come from poverty, gender, and lifestyle choices. So again, you remember back at the beginning in part 1, we listed all of those issues that were health risks, right? We talked about pathogens, we talked about chemicals. Now we're going to talk about poverty, gender, and lifestyle choices. So poverty, the greatest health risk by far. Malnutrition, increased infectious disease, and unsafe drinking water all lead to persons with poverty dying at a much earlier and faster rate than people who are not in poverty. Gender, being born male, actually helps you out at this point, especially in these underdeveloped countries. And lifestyle choices, examples are overeating and smoking, which many people do, especially in developed countries, right? So this is actually one of the most powerful graphs you'll see all year in this class. Basically, what we're looking at is on the left, you're looking at the estimated deaths per year from various causes. Okay, so for instance, poverty, malnutrition, disease cycle, 11 million people. Air pollution, 7 million. Tobacco, 6 million. Pneumonia and the flu, over 3 million, et cetera, right? But what I find very interesting is, first of all, those ones at the top, again, we're talking about poverty, we're talking about air pollution that human beings are putting into the air. Tobacco, right? That's a personal choice. That's a lifestyle choice. But what I find great about this chart is that number in the red here. You see this number in parentheses? This number equals the amount of 200 passenger planes that would crash per day for an entire year. So for instance, 11 million people die of poverty and malnutrition. That's like 151 jumbo jets crashing every day for a year with no survivors. Air pollution kills 7 million people a year. That's like 96 jumbo jets crashing per day without any survivors. Tobacco, 82. That means 82 passenger planes crash per day with no survivors. The reason why the author puts this up here and why I think it's such a great and dramatic graph to look at is, think about the news coverage you would get if 151 passenger planes crashed per day per year. Think about the new laws and the new safety standards that would come out almost immediately if 96 passenger planes crashed per day per year. Think about that. Yet, do you hear a lot on the news about how poverty and malnutrition kill more people around the world than anything else? Right? Air pollution, right? What we hear are companies, big companies fighting, the people who want to cap smokestacks and who want to limit air pollution, right? right? People want to stop. People think, oh, it's not really that important. Well, think about if 96 passenger planes crash per day, what the new safety standards would be the next day, right? So again, I really do think this is a dramatic chart. Look at, for instance, like AIDS, right? 16 passenger jets per day crashing, killing everyone. Right? You would hear about it all over the news, yet really don't hear about HIV and AIDS anymore. All right. So again, very dramatic graph here showing you how what the cause of death is and how we really don't hear much about it, and maybe we really should. The chart on the lower right here, just so that you know, the right graph, this is the poverty, has several harmful effects that make it the leading cause of premature death. So again, this is what this kind of goes with the first chart here, how poverty and malnutrition, right? Adequate to lack of access to adequate sanitation facilities kills 2.6 or at least 2.6 billion people do not have access to adequate sanitation. That then leads to the 11 million per year dying because of poverty. Not enough fuel for heating or cooking, again, deals with the malnutrition, electricity, healthcare, et cetera, all kind of goes into this first bar graph here, which again, poverty, malnutrition, the disease cycle, the largest cause of death out there, premature death around the world. And again, people sometimes, right, or most times, they can't choose if they're living in poverty or not. And that's why this is so sad, because they're going to die prematurely, some of these people who are in impoverished areas or who have malnutrition, really through no fault of their own. Again, tobacco, that's kind of your own fault, right? But poverty, malnutrition isn't really your own fault. And it's sad that that's the leading cause of premature death. 11 million people per year. Again, just like 151 jumbo jets crashing per day with no survivors for an entire year. This graph here is looking at the deaths per year in the U.S. Again, premature tobacco use. Again, number one, that's a lifestyle choice. Accidents from either motor vehicle or other accidents. And there you have the flu, pneumonia, diabetes, infectious disease, excluding the flu. Alcohol use, that's a personal choice, right? Prescription drug overdose, that's a personal choice, right? Illegal drug overdose, that's a personal choice. So again, these are the leading causes of death in the United States. Some result from lifestyle choices and are preventable, like those ones I just described. So talking about some of those preventable ones, right? Cigarettes and e-cigarettes. So cigarette smoking, the most preventable major cause of suffering and premature death among adults, killed 100 million people during the 20th century. Study has linked cigarette smoking to increased dementia and Alzheimer's disease. Nicotine is a highly addictive drug. And secondhand smoke poses health hazards as well. People who don't even smoke can take in that secondhand smoke and can deal with lung issues. So smoking has been on the decline in the United States. From more than 50% of adults in 1950, believe it or not, half the population was smoking in the 1950s, to only about 18% in 2013. Now, there has been a move to these e-cigarettes, substitute for tobacco cigarettes, but unfortunately, the vapors contain toxic metals. Used by more than 13% of high school students in 2014, could be a little higher right now. The European Union has banned the sale of minors, or the sale to minors, of these e-cigarettes. Again, just because you're smoking an e-cigarette doesn't mean you're not dealing with the harmful effects of cigarettes. You may be dealing with other harmful effects like those toxic metals that you are now breathing in. So the last thing we talk about is estimating risks from technologies. So we don't necessarily think of technology and risk hand in hand, but there is some risk involved in any new technologies. So the reliability of a system is equal to the technological reliability times the human reliability. The human reliability is going to be much lower than the technical reliability because it is much harder to predict. So just understand that. Again, nothing major here, but there is a way to estimate risk from technologies as well. Most people, though, do a poor job of evaluating risks, factors causing misjudgments, fear, degree of control, whether a risk is catastrophic or chronic, Again, does it happen that acute right away, or maybe it'll affect me 30 years ago, so I'm not going to care. Optimism, bias, and instant gratification can also be an issue. So guidelines for evaluating and reducing risk: you want to compare the risk, you want to determine how much you are willing to accept, you want to evaluate the risk involved, and you want to concentrate on evaluating and carefully making important lifestyle choices. All right, so that concludes my lecture on Chapter 16, Environmental Hazards and Human Health. And as always, thanks for listening.